Now we're going to take a look inside a smartphone that contains a Snapdragon 805 chip from Qualcomm Corporation. Now before we do that, let's look at a lot of smartphones that have a Snapdragon 800, 801, or 805. So if you have this phone, depending on the model, you may have one of these Snapdragon chips. And so the chip that we're going to go over in this course is very similar, or maybe the actual chip that you have inside your phone. Let's take a look inside a Nexus 6 smartphone, which was released by Google and Motorola near the end of 2014. Now, if you were able to open it up and you looked inside, what you would see is a logic board that looks like this. Now, if you opened up your own smartphone, you'd see some kind of logic board with electronic components on them that are wired together through this board. Now, there are a lot of different components on this board. We're going to focus on the ones that correspond to the computer system part of your smartphone. So first we have this component here, and actually this is two components, one stacked on top of the other. Now if you're looking underneath this top component, you would see the Snapdragon 805 package. Now this chip is inside a package to hold that chip. And on top of that is a memory chip. Now this memory holds the instructions and data for running programs, and we'll talk about this later in the course. Now here's another chip, which is the flash memory. Now this is where your apps are stored. So we're going to talk about how this flash memory and this system on chip, this Snapdragon 805, how they all work together in this course. Now let's look closer at the details of the Snapdragon 805. We call this a system on chip, or SoC design, since this single chip contains pretty much an entire computer system, including specialized processing engines for handling tasks like graphics and video, all in a silicon chip that's about the size of a fingernail. Now if we look closer at this SoC, we have a lot of different components, and there's a lot of acronyms here. Now don't be intimidated by these acronyms. Some of these are product names from Qualcomm, others of these are engineering standard names. You're not going to be expected to know all these names, but I left them here so that you can go off and look them up on your own if you're curious. First, let's look at what's called the general purpose processor, which we're going to call the apps processor in this course. Now this is the processor that runs your apps and is the focus of the technical details of this course. Now Qualcomm makes their own processor, which they call Crate, and actually it contains 4 processing units, which we sometimes refer to as central processing units, or CPUs, or sometimes you hear these called cores. Now each of these CPUs can run an individual app or different portions of the same app, as we'll see later on. Now also on this chip are controllers, for instance for getting information to and from that memory that's sitting on top of the Snapdragon 805 package. Now this chip also has a number of specialized processors for handling specific tasks that you do on your smartphone. So first there's the GPU, or the graphics processing unit, which handles the processing of screen graphics. And then there's the display engine that transfers that graphics information to your screen. Now there are also a number of processors for handling media, such as playing ultra-high definition video and music. In fact, this chip supports 4K video. There are also special image signal processors, or ISPs, for handling input from the 2 cameras. There are specialized processors for handling sensor inputs. There's a GPS and other location functionality. And there's a universal serial bus, or USB controller, and this is an engineering standard for doing communication through wires. So for instance, to connect your smartphone to your laptop. In this corner we have this overlaid block. This is for the communications. For instance, cellular communications to communicate with a cell tower. Now it's overlaid because in the 800 and 801 chips, these functions are actually on the SoC. But in the 805, they decided to put those on a separate chip. Now that seems maybe a little bit non-intuitive because an 805 is a newer product, but there are different trade-offs for putting this functionality on the chip versus off. So for instance, you might consider other functions that you may want to put on the chip in consideration of cost. So for the 805, it better handles 4K in all respects than the previous 800 and 801. Also, there's evolving communication standards, and those may or may not line up with the development cycle of making a chip like this. So although you may think that every new chip is going to have more on it, from an engineering standpoint, it may make more sense to leave that functionality off and put it on a separate chip. Now that we've seen an overview of the 805, let's see how it operates when performing a complex task like playing a game. First, there's the Crate quad-core CPU. These are the general-purpose CPUs that orchestrate gameplay, that handle artificial intelligence of non-player characters, they handle animation and physics of collisions and particle movement and those types of things. Then there's the graphics processing unit. This provides the lighting, the shadows, the reflections, all of the graphics that you see on your screen as you play the game. Then there are audio files that need to be processed, and there's a special digital signal processor on the Crate chip for efficiently handling those types of operations. Then there's a special video decoder, which handles any video associated with your game. Now, you'll notice that the system memory has a bunch of files, a bunch of information. And that's that system memory that lies above the Snapdragon 805 in a separate package. And finally, we have the display engine. This is a specialized unit on the Snapdragon 805 that reads the information that's created by the GPU and by the video decoder and then sends that to your display. Now, there are two big advantages for organizing the SoC in this way. Now, the first is performance. By having all of these specialized processors for doing audio and video and graphics, as well as the general purpose CPUs working at the same time on their tasks to play your game, well, that's an example of parallelism, where all of these different tasks are being performed at the same time. And that's higher performance than if we had just one processor that had to perform all of them in sequence. Now, another major advantage is energy efficiency. It's far more energy efficient to have, say, a specialized video decoder to perform video functions than to do those on the general purpose CPU. In fact, studies have shown that you can save over half of the energy that you expend on a general purpose CPU for that task by having specialized hardware to do that. And so your battery life is going to last a lot longer by having all of these specialists in addition to the general purpose CPUs on your smartphone SoC. Now we'll look inside the details of the Crate CPU. And let's explore this from the perspective of the computing technology stack. First of all of this is constructed using digital logic. At the lowest level of the stack, we have transistors and wires that connect those two. Now, your smartphone SoC these days may have billions of transistors that are interconnected together. Now, these transistors are put together in things called logic gates. And we use these logic gates to build useful logic functions, things that allow us to, say, select two values or to store numbers. We also use these logic gates to construct controllers, which allow us to orchestrate the flow of data through the computer. Now, above digital logic is computer organization. Application programs that run on a Crate CPU run an instruction set called ARM, which has certain definitions for things like the type of instructions that you have, such as add or subtract. We also have the hardware design, or the microarchitecture, with specific steps for processing each instruction, such as instruction fetch, instruction decode, operand fetch, and execution, and methods such as pipelining, superscalar, and SIMD that make our apps run so fast. Now, don't be concerned if you didn't understand much of this material. I wanted to give you this information so that you have some context for where we're going in the course. And in fact, at the end of the course, we're going to revisit the same material, and you'll have a deep understanding of how a complex CPU like the Crate processor works in your smartphone. You'll also be able to apply the principles and performance techniques of a general purpose CPU to these other specialized processors that are on a smartphone SoC.